each of these presentations, I quickly come to the realization at some point decisions have to be made, and in that process, values have to be assigned to various parameters within those decisions. And I was thinking about that in the context of, during the break, there was an undergraduate student came up to me and said, "What's the most important place for leadership today?" And I said, and probably a surprise to her, I said policy. Because I think very often today we have those sitting in the key positions when these decisions that influence policy are made who lack the kind of background that we've heard from each of our speakers today. And again, as I think about what I would encourage this profession to do, don't be averse to becoming engaged in those kind of opportunities as well. We turn now to climate change, and Dr. Jim Jones is coming to speak to that. He's the director of the Florida Climate Institute and co-leader of the, and he might explain this, Ag-MIP Global Program. Also emeritus professor in Agricultural and Biological Engineering Department at the University of Florida. He's been a fellow of ASABE since 1990. He's a fellow of the American Society for the Advancement of Science Society. I'm messing everything up today. Soil Science Society of America, the American Society of Agronomy. In 2012, he received the John Deere Gold Medal Award and the Kashida International Award in 2005. In 2012, Dr. Jones was elected to the National Academy of Engineering. He specializes in agricultural production systems analysis, simulation, crop and soil modeling, environmental effects on crop growth and yield, and computer applications in agriculture. Dr. Jones. Thank you.
Thank you very much, Robert. It's really a pleasure to be here, and I would also like to thank the organizers, ASABE President, and the organizing committee for creating this special occasion today. I think it's really important, and I do hope that it continues to flourish in all of the meetings as we go forward. So I'm going to talk about climate change today. It's a topic that many of you have heard an awful lot about. There are a lot of talks given about it. But it's clearly one of the global challenges with many uncertainties, of course, and variations in what this means over time and space. I was pleased to see at this meeting there were a number of sessions on climate change, and particularly in the soil and water division or community. And I think in the first talk this morning, we heard that irrigation and drainage, of course, are major challenges as we go forward with climate change. But climate change touches everyone in agriculture, and not just in agriculture. It touches everyone. It's truly an important issue, and yet there's still denial by many people who are, considering the challenge of climate change. The policy that Dr. Easter mentioned just a moment ago, I mean, it's really a challenge for us in many of the countries. I've got a couple of slides here showing a recent report that came out of a bipartisan committee stating that climate change and variability pose significant risk to human and natural systems, and that this was findings of an independent assessment of impact of climate change on county, state, and regional levels in the U.S. And of course, we've had IPCC and national climate assessments and many other ones. But one of the things that was significant about this report is it's bipartisan. There are Democrats and Republicans and independents that make up the report. And so they were talking about the importance in the U.S. economy of that. And one of the other really important aspects of this report is that they singled out agriculture as being really susceptible and vulnerable to climate change. And one of the reasons that I thought that this was significant is that we are continually losing funding in agricultural research and development. And the more that we can bring these issues to the forefront, and not only ourselves as ASAB Society and other societies, but to have these, this independent bipartisan group bring to the forefront the importance of climate change on agriculture and food security is, I think, very, very meaningful. So the key questions that were posed to me as I was asked to prepare these comments were, if the current trends in climate continue, what are the significant impacts that are likely to affect agriculture? And what role should ASABE members play in mitigating them? And how should ASABE prepare for and anticipate significant random weather events and climate change? I can't promise you that I'm going to answer all of these questions, but I'm going to give you some ideas, at least that I've created from my background, that I think would be real important for us to consider as we move forward. Now, climate change has both direct and indirect effects on agriculture. And the direct effects, of our biological productions enterprises are affected by increasing temperatures, the higher frequency of extreme heat events, the changes in drought patterns over space and time, excess rainfall and flooding. There's a higher frequency of intense rainfall storms. And also the higher CO2 concentration that interacts with all of these other factors, and sometimes difficult to predict ways. But in addition to that, there are many indirect effects that climate change is having. And we've talked about some of these other interacting factors this morning already. I mean, the challenge of water security, energy security, food production, population increases that are occurring have led to food and energy price spikes. And the bottom left graph there shows some of the price spikes that have happened in the last several years for food. Increased water scarcity, and we've heard about that this morning in a couple of talks. Land degradation, as more and more land is brought into production, some of these are marginal lands and they're more susceptible to erosion and salinity and other problems that we have to deal with in agricultural and biological engineering for producing our food and fiber and energy. And of course, there are political instabilities and conflicts, and in some cases caused by some of these other interacting factors that and challenges that we're talking about today. There's competition for arable land to expand production, and then on top of all of these, if we didn't have climate change, we would have enough problems to deal with as ASABEers. But you add climate change on top of that, it further exacerbates all of these problems that we have to face. And there's plenty of documentation now, and the international climate change community, as well as the national climate change. This is some from the recent 2013 National Climate Assessment that was done in the U.S., showing the fact that between 1991 and 2012, temperatures have increased already in the U.S. And you see those patterns there, and of course there are some places, like in the southeast, where it hasn't increased nearly as much, and in fact in some places the weather stations show that it's decreasing. But certainly as a whole, temperature is increasing across the U.S. already. On the right-hand side of the slide shows the percent change in the amount of precipitation falling in heavy events. In other words, is a measure of the intensity of rainfall, and from 1958 to 2012 for each region. And you can see in some places, like in the Northeast, 71% increase in precipitation coming in heavy events. This has major implications in drainage and erosion and all of the things that our Soil and Water Division have to deal with. Temperature also has major effects, and if you look at the global IPCC projections under two different scenarios of greenhouse gas emission, the low one on the left-hand side shows even with the low emissions, we're going to get somewhere around 1.5 to 2 degrees more increase. But the way greenhouse gas emissions are continuing, it's more on the pathway of the 8.5, RCP 8.5, the representative concentration pathway of 8.5 watts per square meter. So, and the climate models mostly agree on this temperature changes. Precipitation is not so clear. There are differences among the models, and there are also differences over space. But the one thing that has been shown is the intensity, as I've shown earlier, is a major issue to deal with. And then these are some of the global temperature increases on the left, showing the RCP 2.6 and then RCP 8.5, showing up to 4 to 5 degrees Celsius temperature increase. On the right-hand side is something that people maybe in many parts of the U.S. aren't as worried about as we are in Florida, but that's sea level rise. And if you can see some of the maps that we create in Florida with sea level rise, and you see that that's going to be a major problem around the coast where much of our population lives and all the infrastructure is there. And the implications of that are migration, if and when that happens. And sea level is continuing to rise. Some of the direct effects of climate change on agriculture is represented here in this cartoon. There are possible benefits as well as drawbacks to these increases. And in the benefits, CO2 increases are, of course, plants like CO2 increases. It increases photosynthesis and dry matter production and therefore yield if you have enough of the other resources for producing it, like nutrients. And they don't cause so many pest losses. In some places, like here in Canada, you're going to experience and are already experiencing longer growing seasons that crops can be planted. And the increased precipitation events, I've already increased precipitation in some areas I've already talked about, but then some of these may be quite heavy. On the drawbacks, there are more frequent droughts projected in many places. And also the biological responses of crops are such that the plants will go through their life cycle much faster in the current germplasm that we're using, just because the biological activity is so much faster, and you can have a 130-day corn plant that may mature in 110 days. And if it's not there intercepting light and producing photosynthesis, the yields are decreased, sometimes dramatically. And also the higher temperatures also increase respiration and cause lower grain set in many crops. And so there are many interacting effects that climate change will have. And I've already mentioned the increased flooding and salinization associated with irrigation. So if the current trend continues, well, there are already many different climate change impacts that have been done. There are likely to be winners and losers. And the gentleman from South Africa talked about land grabbers, and you know, I'm sure that some people are looking at the future climate conditions and basing their decisions on where to grab land based on that. But the third point I wanted to make on this is that agricultural models, biophysical models, are used in these assessments. And this is another area where agricultural and biological engineers are playing and can continue to play an increasing role for integrating all of this information and understanding about what's happening both in the biophysical world but also in the food chain systems that more and more need to be taken into account as we continue. This is some of the work that we've done with the crop models that we've developed, and now just like the climate modelers, we're using multiple crop models, and I'll talk about that a little bit later on in the talk about AgMIP after lunch. But this is a paper that we published, and Cynthia Rosenzweig is a senior author on that in the proceedings of the National Academies of Sciences recently, showing that we can now show where there's agreement in the projections of yield losses associated with climate change and the different climate models that are used. So I think a very good contribution from these models. And our economist friends are also playing a strong role in this, and they're using results from these biophysical models, also population increases, changes in demand for water and energy, and integrating these. And this is a comparison of 9 different global economic models that we did in the AgMIP program. Again, showing that in contrast to the previous assessments that have been done, where price trends that have been happening for food have continued to trend downward, these models are all showing that in the future, around 2050, that there is very likely to be some major price increases in food that we're going to have to contend with. And that's taking into account some of the adaptation that we think can be done. Of course, not all of the innovations that we need to develop to avoid some of these price increases, but it's really interesting to see that all of these are showing that there is a reason for concern and reason for action today, not in 15 or 20 years. The National Climate Assessment, I would just put this in here to point out that there have been a number of national and regional climate assessments. And the AgMIP program, we're also working in sub-Saharan Africa and South Asia with teams who are themselves conducting their own impact assessments using methodologies and the tools that we're helping them with there. And this is funded by the UK aid in the UK. So then just a few slides about how ASABE can help prepare for the future. And I'll point out, first of all, that there are many global initiatives that I think ASAB members need to be more actively involved. I know many are involved, and you'll hear from some of these, are hearing from some of these today. But I think we have an awful lot to offer in terms of these different initiatives, including climate smart agriculture. I don't know if you've heard about this or not, but this is a major initiative of the World Bank and FAO, and the CGIAR is involved in this now quite heavily as well. Sustainable intensification is something that is looking for innovations for increasing food production in sustainable ways that will help solve the food security problem. Feed the Future program in USAID. There's a climate resilience fund that was just announced last year by President Obama, where there's public-private funding for for combining support for public-private partnerships, and then there is increasing interest in many organizations in the private sector for public-private partnerships. So I think there are many opportunities there. I've listed a few here for a few examples, but I think the take-home story of my talk is that in every division and every community in ASABE, there are opportunities and really needs, important needs for our members to take into account climate change as you design those new systems and analyze these new opportunities and develop these new technologies in every single division. Here's some that I've been close to. First one is to improve agricultural system models. This integrates knowledge across disciplines and is very much an interdisciplinary activity, but it needs to be done so that the models that are coming out of that are practical. There are models that are for only scientific curiosity, and there are also models that are developed for solving problems, and we as engineers, of course, are in the latter category mostly. And so, and there's a need for this, and this is an example of comparing some of the different crop models around the world now in predicting evapotranspiration. They all do a fairly good job of predicting evapotranspiration under current climate conditions. When you start increasing CO2 and temperature, that you can see the spread go out. And why is this? What are the reasons for this? And certainly we need to improve these models to do, I think, a better job of predicting these processes. Another opportunity, I think, is for the biological engineering components in ASABE is to increase collaboration with molecular geneticists and plant breeders. Plant breeders and molecular genetics folks are working to design new plants, and they need to have new systems, new production systems, in order to grow these new plants. And that's where ASABE comes in. Also, even in developing models that take into account these molecular genetics information. And this is an example of a gene-based model that we developed for predicting the growth and development of soybean. And in fact, we did this in Florida, but then we applied it in Illinois, and we showed that it worked quite well for these phenology characteristics there. So looking for engineered solutions for resiliency, sustainability, and adaptation to these climate change challenges. Precision agriculture is another one. We, in terms of increasing productivity and reducing environmental contamination, we need to know what the plants need, and we need to be able to develop systems that will sense these needs and provide in the right amounts and at the right time so that we get the increases in production but without the side effects. Major opportunities, I think, here as we continue this. In terms of reducing greenhouse emissions, increasing water use efficiency, and now with some of the new methods. This is Bruno Basso from Michigan State, actually, Ajit, who's working quite a bit on precision agriculture. But anyway, there's just a lot of opportunities, I think, to provide the technologies and the models and other information that we're developing in ASABE. A fourth one, I was really interested to hear the gentleman from China stating that there were 500,000 hectares under greenhouse production in China. That's amazing. And, you know, probably in some of the places where climate is changing, we may need to look for solutions that would include greenhouse production. And one of the programs in Florida is actually doing that. We we are looking for ways of reducing contamination of the environment as well as greenhouse gas emissions and increasing profitability and reducing risks for profitability. The last few slides here are just a plea to consider the big picture as we think forward. Typically on this graph, we show climate change on the horizontal axis and benefit from adaptation on the vertical axis. And the first curve there that goes in plateaus in a solid line shows the sort of simple things that we can do to adapt to climate change, like changing planting dates if we have longer seasons. And in fact, that's already been happening. If you look at the planting dates in the Midwest in the U.S., I mean, they've been increasing by at least 2 or 3 weeks over the last 50 years, and increasing production as associated with that. But then if you look at the very top curve, where there needs to be a transformation, there indeed will be places where transformations associated with climate change will have to take place. I can't predict all of these at the moment, but I think we should look for opportunities for changing agricultural systems to take advantage of the future climate. This is a graph showing the current USA drought monitor. California has been in a drought for 4 years, and the projections aren't any better. If you look at the future of on the left-hand side, it's the current drought conditions across the U.S. On the right-hand side, it's a projected number of dry days in 2070 to 2099, and you see the same parts of the country affected that are already being affected through the changing climate that we already have. So how should we respond to this as a society? There are different possible examples, but one of the things that we think is possible is to look at expanding irrigated crop production in other areas of the U.S. or other countries where it's more efficient to irrigate. They irrigate quite a bit in California. The water supplies are diminishing. Climate change is happening. And so there's a project in Alabama with University of Alabama Huntsville and Auburn University where they're looking now for increasing irrigation using water captured during the wintertime when runoff is high. If lots of rainfall and runoff is high, and so they can capture that and use it for irrigation with the subsidies that went into creating the dams in the West. If there could be some programs to help develop this system in the Southeast, it would be, I think, a boon to the economy and help replace some of the lost food production that will occur in California. So this is the last slide then, and what are ASABE member roles? And I've said this already, and this is really the take-home message, is that every division and community in ASABE can and should play increasing roles in developing predictive understanding of the components, and designing new solutions for increasing resource use efficiency, increasing productivity and profitability, and reducing risk to the economy and also to natural resources and the environment. There's a wide range of entry points. We heard about some of these earlier today already, from molecular to sensors to control systems to harvesting, processing, packaging, housing, waste management. I mean, all of you in those different divisions, I know, can think immediately of ways that you can, perhaps are already doing some of this. And then the final point there is to take advantage of this increased interest in public-private partnerships. As engineers, we should look for ways to both maintain our ability to publish papers in the public sector and have public good research going on, but decrease the amount of time that it takes for that new knowledge to go into products. And I know that ASABE is doing a lot of that already, and I would call for even more now, and I think the interest is there to do that. So thank you again for inviting me here. I really appreciate this opportunity to be with you.
I'm listening to this presentation. I'm reminded of a book that I was very fond of as a young person, Robinson Crusoe. Probably not many young people read today about Crusoe, who was marooned on a deserted island. And for a while, he lived off of supplies that he found on the ship. But after those were gone, about the 4th chapter of the book is titled, I Must Invent to Live. And actually, I think what we recognize is that as we go forward with climate change and other challenges, the survival of the human species depends on our ability to invent to live.